as the pinion. All those components will come into picture in the component or part design. So in that, we design the part in CAD softwares. So there are numerous CAD softwares used by the OEMs. The CAD software such as CATIA, SolidWorks, you might be aware of some, and some new softwares are being introduced in the OEMs nowadays. All these part design is done in CAD softwares, and we get to visualize them, and then evaluation begins. So evaluation in the sense finite element modeling, and then computer aided engineering. So we get to test the part as well as the component in the software itself. So we first initially design the part, and then we get to test the part in the software. So the softwares that we use for FEM are ANSYS, LS-DYNA. LS-DYNA is used for crash simulation, and then we have Star CCM, Fluent, all those for CFD analysis, and all those softwares help in analyzing the parts as a whole. So, and then we begin our prototyping. So we begin the prototyping of vehicles. So once the validation begins, we get to prototype the vehicles. So initially a batch of 10 to 20 vehicles are built as a prototype, and those prototype vehicles are tested rigorously. So after while testing, we get to see a number of failures, and then those failures are captured, and then we get to change the design to rectify those failures. All those lessons learned will be taken, and that will be incorporated into the further design process. And then after the testing of the prototypes is done and all those failures has been captured, once the vehicle is completely ready to be produced, that is ready for start of production, and then we sign off the complete CAD of the vehicle, and then we give to manufacturing. So then the manufacturing job begins, and that is a whole different picture. So manufacturing has its own difficulties as well as supplier integrations there. So all these process, the whole process of vehicle development begins with the requirements, and then we finally come up to a whole vehicle. So after a whole vehicle CAD is ready, we go for production. So this is the process that followed in OEM. During that process, many optimization techniques are brought in. So these are the stakeholders in the process. So we have discussed about the process followed in OEM. So each system has a stakeholder. So initially, studio design. Studio design deals with designing the concept designs of the car. So the sketches that you see as sketches, as well as the renderings of the car that you see initially while the conceptualization phase of a car is done by studio design. So each OEM will have a design department. So the design department will initially put up sketches, and then they will come up with renderings. So we get to visualize how the car will look like. And once the design is finalized, then the vehicle architecture department comes in. The architecture department deals with the packaging aspects. So in the packaging aspects of a car, we define the space for each of the component. So what will be the seating capacity of the car? So will it be a 5-seater or 7-seater, or we go for a sedan or a SUV? So all these are defined by the studio design as well as the architecture. So the design and architecture department works hand in hand, and they will come up with the final rough architecture of a car. So while building a house, how we see a plan. So the design and architecture department will come up with a plan. So that is the initial architecture phase. So once the architecture phase and all those things are finalized, whether we finalize to be a 7-seater SUV, then we go for the detailing phase. So all the detailing is then done by each of the department. So we have body in white. So body in white is nothing but the body top hat of a car. So what you see in the car has two parts. So the underbody as well as the top hat or the top upper body. Okay, so the upper body is constituted of body in white. So body in white, it may be a new term to you, but OEMs use it often, and it is the most important part of the car. So every OEM has its own trademark BAW, and then we have CAE. CAE, few might be aware. So those in third and final year might be aware of CAE. So those in first year and second year, it might be new to you. Computer aided engineering. So computer aided engineering, we have numerous tools to help us in CAE. So what we do in CAE is we get to analyze various performance attributes of the components. So we have durability analysis. Those in production and mechanical might relate to it. So durability analysis, we get to do the fatigue analysis of the parts. So fatigue in the sense the cyclic loading and reloading of the parts, and then we do the noise vibration harshness test. So NVH, in NVH we test. NVH is very important in designing the parts. So more importance is given to NVH. So each NVH testing phase takes a lot of time, and NVH we do the model analysis. Not, we also do nonlinear analysis for the parts. Then we have crash analysis. So crash analysis is done as a system as well as a whole vehicle. So what you get to see in the crash videos that is circulated in the social medias, so the simulation as well as the actual footage of the crash must correlate. So the correlation of the crash simulation must be above to say 80% must be good. So the crash department works for that, and we have LS Dyna to support us in crash simulation. So we have a software called LS Dyna. So the crash department uses that software and simulate the crash analysis for the parts as well as the car level. Okay. Then we go to dynamics. So in the dynamics, the analysis, we have all the um, you get to know the powertrain department is covered in dynamic analysis. So they get to test the fatigue of the gears, the transmission shaft, and all those components are then used analyzed in dynamic analysis. And then we have CFD. CFD is mostly used to cover uh, the drag force, and then we have fluent how the fluid is moving in an engine. So engine department uses CFD analysis, and then we have fuel injection. So how a fuel is injected, so they use CFD for their analysis. And then we have engine oil, how the engine oil is circulated, is moving in, and how the heat is getting transferred. So all those analysis is covered in CFD. And then we have DAC, drive away chases. So as I said, the underbody is named as drive away chases in the OEMs. So the underbody consists of suspension, brakes, wheels, and steering. So all these departments works as their own on, and they collaborate. So um, these various they will get to work on their own software such as Adams, MATLAB to simulate their suspension systems, and then we have brakes. So these all systems come together as a cross-functional team, and they uh, finally come up with their performance attributes for the vehicle as a whole, and finalized, and the final performance attributes is set. So all these departments are there, and then we have powertrain department. So engine and gearbox. So how much power is required, how much torque is required. So all these is done by them. Then we have electrical. You know that, right? So the headlights, the horns, the instrument cluster, the infotainment screen, and all those electrical systems like the ABS, ESP. All those systems are covered and covered under electrical department. So these are all these departments in a OEM. So not OEM, automotive OEM. Okay. So I'm just giving you an idea how the structure is in an OEM and how they work as a team to build a car. So these are all the teams, and they will work as a team to come up with the uh, good car. So okay, and then we have the manufacturing team, and so manufacturing, we have in-house manufacturing, and then we have supplier parts. So finally we have an assembly plant. So all these things are covered under manufacturing, and these tools are used. So these are the tools used. I mentioned few, and in CAD we have CATIA, Creo, and XCAD. All these tools are used, and then CA we have ANSYS, MATLAB, LSDNA, etc. Akash.
Yeah, I guess that's too much information on a Sunday evening. uh, okay, so Lakshman and Peramal has told about all the departments, but it might vary from different OEMs. Say, for example, at Tesla, we might have autonomous division. We might have more software engineers and more software teams inside Tesla. So it depends on every other OEM. Also, when you see the parts now, we divide parts into, manufactured parts and bought out parts. Some parts we decided to outsource. Outsource the whole part from a different company from their own design. Some parts we design it ourselves and we do manufacturing by ourselves, or we outsource the manufacturing alone. So that's how we separate parts into two. So that's why we have in-house and supplier parts. So when we see all these teams now, they work at different places, different office. Nowadays they work from home. So these are the tools they use to collaborate. So mainly, if you take any hardware company, they use a software called PLM. Okay, PLM is nothing. It's like GitHub for manufacturing companies or hardware companies. Okay, in GitHub, as you are all in from IEEE, you might be knowing about GitHub. So we have our code repositories. We do version control on GitHub. So similarly, PLM has all the CAD and all the CAE details in stored there. So we'll be also having versions. Say for example, if I design a car and say it has a different wheel design, so that will be version 1. If some other, based on some other inputs, if I change the design, it will be version 2. So I'll be changing the version in the PLM itself. Say for example, some guy from the chassis team, if he wants to add a wheel, he'll just go to the PLM and take the latest design from the PLM. So that's how PLM works. So the PLM is connected to all other softwares, CAD, CAE, ERP and all. So once, say for example, all the design are done and we are released everything to the PLM. So from the PLM, we want to outsource it, right? So now it has to go to the vendor team or purchase team or the finance team to cost it. So it goes to the ERP system. So that those teams can collaborate there. So the engineers team will be collaborating on PLM. From PLM, data will be going to ERP. So from there, so those things will collaborate. Yeah, so also Perumal mentioned a lot about OEM. So OEM is nothing but the original equipment manufacturer. So the name, the brand which we see on the phones are the OEM. Say for example, Perumal works at Mahindra, but Mahindra doesn't manufacture all the parts inside the car. So they have various suppliers like Bosch, Jetta, Continental, TVS. So they supply parts to Mahindra. So the companies which supply directly to Mahindra, they are called Tier 1. Say for example, we have an example on this slide, example of spark plug. So in this example now, usually Bosch applies spark plug to all automotive companies. So here Bosch is a tier 1 supplier, and for Bosch, the Kumi might be supplying some material. Say for example, ceramic coatings on the spark plug that might be separated from Kumi. So they might be tier 2. So TVS might be tier C supplier. They might be supplying fasteners, nuts, and bolts to Kumi, not directly to Bosch. Through Kumi, they might be supplying to Bosch. So they might be tier 3 supplier. Also, it goes to tier 4, tier 5, and tier 6 based on the product. Say if the fastener requires other process which is sourced from a different company, in say for example a small scale company in Coimbatore, they might be called as a tier 4 supplier. So like this, we have a lot of levels of suppliers within a company. So that's how parts get manufactured and assembled. Yeah, so we have an activity for everyone here to make the session less boring. So Lakshman Burma.
Yeah. So the outcome of this session, I asked Sintra Ganesh, and he wanted us to help students to generate ideas. So I put up a slide, put up an image here. So this is an windshield wiper system. So uh, the conventional wiper system is pictured here, and what could be done. So I want you guys to come up with ideas. What can be done in the windshield wiper system as an innovative solution, but the problem statement remains the same. Okay, so I have to wipe my cars in the state of rain. Okay, so the rainwaters I have to wipe from my windshield. So that is a problem statement, but I want some innovative solutions from you guys, and we will go and see how the industry is doing. Okay, so I want some interaction from you guys. Akash, you can present your screen.
Yeah.
Uh,
Someone
uh,
from the organizing committee, please make sure
yeah.
everyone responds.
We don't want the session to be monotonous, so
Yeah, just come up with random ideas like,
like it could be it doesn't want to be feasible. Like, okay, so there is.
say for example, you sit in an interview, then the interview asks if give a different solution to wipe the water, so we'll get placed. So at the time you might be coming with some random
Akash, we
ideas.
have ideas coming up in the chat room.
Oh, wait, I'll project this.
Anna,
Yeah, hi.
may I say?
Yada, go on.
Yeah, yeah.
We can use a jet stream to remove water. At the top of the rim, we can use jet engines. So we could shoot out the air to push the water away.
Okay, nice.
Nice idea.
Okay, we
Different
have
type.
a few hydrophobic windshields, left to right wipers, super hydrophobic coating,
Uh,
oleophobic coating. Okay, nice. Changes in 4-bar mechanism, placing sensors to sense water and actuate. Okay, nice. Good to see all the responses. Using heat from radiators to melt the fog away. Okay, or some design changes. Okay, nice.
you guys might should take this as a problem statement and build something.
Yeah, Nandita, see, you have raised your hand. You can go on.
Embedded
Embedded.
thin heating wires in glass.
Okay,
Wow, that's cool. Vishal.
that is actually there in the cars. Vishal, that is actually there. So that is a good idea. So you can we can work on it to improving that.
Okay, so you can
Yeah, correct. There is. Yes.
using two wires in the rear windshield and the front windshield so that in mental pieces we can comment on that problem.
Correct.
By using high current we can heat up the glass to make that clear. So thank you. Thank you, sir.
Yeah, correct. Thank you, Vishal. Changing the design of wipers so that we can clean the glass completely. Nice. So now we get to clean only partial glass, and then you want to clean the complete glass. That is nice.
Actually, this is how brainstorming happens at companies, right? From
Yeah,
Perumal.
yeah, correct.
They just
So
yeah,
I
they
want
just
to
put questions and
yes,
yeah.
this is how a brainstorming session happens, and ideas are being generated here, right? So you get to see how you have a few ideas on hydrophobic glasses, and you have a few ideas on design changes and electrical heating and many more, right? Okay, so now we will see how the research is being done in the industry and what research is done being in the worldwide. Okay, so we have So we have a wiper system. So it affects, so what it affects and how it affects the overall performance of the car. Okay. So the OEM will think in that aspect also, not only in the problem statement of wiping the windshield, but also in the overall performance of the car. Okay. So in that aspect, we have the NVH attributes. So while wiping the windshield, so we don't want to see any vibrations in the windshield, which will affect, which will bring more noise into the cabin, or which will give more vibrations in the windshield that you don't get to see clearly. Okay, so the NVH requirement is there. And then we have aerodynamics requirement. So you are moving at a speed of 70, and you don't want to see your rainwater going here or there. So we have aerodynamics requirement, and you don't, aerodynamics also creates a noise which will come into a cabin. So you want to design your wiper system in such a way that the rainwater goes away from the windshield without creating much noise. Okay, so there is a aerodynamics requirement also. And then we have material requirement. So now industry is researching on new materials which will reduce the scratches in the windshield, or which will give more life to the windshield blade, so the wiper blade. So the wiper blades nowadays, we use wiper blades for around 6 months or some time. Okay, so our industry is working on to increase the lifetime of the wiper blades. So new materials are coming up. So the materials science department works for that. The CFD departments works in the aerodynamics requirement, NVH analysis. The NVH CA team works on the NVH. So to come up with a good wiper, so we need not only need uh, the good wiping system, but also we need to consider all these requirements as a whole. Okay, so the NVH, if we see NVH, if we take NVH, so there are numerous research going on in the non-linear analysis of the, that is the uh, so there is an effect called the wiper arm deflection. Okay, so the wiper arm deflection must not be there while the functioning is happening. Okay, so if you search for these particular topics, like I want to improve the NVH of the wiper blade system. Okay, so you get to see a numerous papers published on this topic, and you can choose a topic and work on that. Like I want to increase my or I want to decrease my noise, or I want to optimize the noise coming out from the wiper system. So there are numerous topics available here, and you can choose a topic here also. So the aerodynamics. So I want to optimize the aerodynamic flow uh, in the wiper blade system. So if I search for that topic, then I get to see a numerous papers published on that and a few patents too. So in likewise, I want you guys to choose a particular topic and go deep into that. Like what are all the performance requirements and what it affects as a whole in this overall system. So you can work on that, and you can choose a topic, and you can work for, on improvising the already published papers too. So there will be so if you take a published paper, so the end result of the paper will be a future scope. So you can read multiple papers, and you can read the future scope available, and you can work on that. Okay, so these are all systems with wiper systems. Okay, so the Tesla, so the Tesla company has come up with a non-conventional type of wiper system. So they have taken out the electric motor in the wipers. Okay, so if you take a wiper system, conventional wiper system, there will be an wiper motor assembly and then the wiper blade. So what Tesla did was they took out the wiper motor. What they did, they introduced the concept of magnetic levitation. You guys might be aware of that. So they place a block of magnet, and the magnet moves here and there while you supply the current. Okay, so instead of a motor, we have a block which moves to left to right. We have only a single blade. Instead of two blades, we have only single blade. Okay, so this is a different approach to the problem where they never considered the conventional wiper system. Okay, so this is one of the solution by Tesla, and the other you've seen, right? The laser wiper system. Okay, so they took out the entire wiper system out of the box, and then they put in two lasers which will wipe the windshield in case of rain as well as dust. Okay, so all these are patents applied by Tesla now. uh, I why I have put such images here, right? So I want you guys to think in such a way that you not only work on the conventional system but also think out of the box to bring in more innovative solutions to the problem statement. So we have a few comments on the chat room was hydrophobic glasses, right? So one of the research in University of South Australia is a windshield glass without uh, uh, which doesn't hold rainwaters. Okay, so the hydrophobic glass is an solution which you guys have proposed, but the research is already going on in University of South Australia. Okay, so these are all the works being carried out in the industry as well as the um, community as a whole on the single part wiper assembly system. Um, there are numerous parts available in automotive field, not only automotive field but other fields also, where you guys can work. This slide just might give you an idea how to approach a problem statement and how to work on that, and how do you guys come up with a solution for that. So I guess you guys
Yeah.
have got the knack of it. Yeah.
Yeah, even if you see here now, so in all these three examples, I mean all these three proposed solutions, they have less number of components. So less number of components, you'll have less manufacturing cost. Also, you have less problems in the assembly line. You can manufacture more parts. So yeah, these are some advantages when we see manufacturing, when we see from manufacturing aspect. Yeah, so when I asked Suntra, he told me, so this session, more mechanical and I mean production engineers will be attending this session. So I made a slide regarding, I mean, what type of work, I mean, what type of roles are available in a traditional automotive company. So when I was in college, I was not sure about these roles. So I thought, okay, we'll go design a car, or build a car, or something like that. But they have clear set of roles and responsibilities. We can categorize it as four. I mean, design and development, manufacturing, supply chain, and business. So the most engineers are hired in design and development, because when we see at scale manufacturing operations, supply chain, and business, we do have a lot of people, but research and development takes a lot of effort and human time. So they hire a lot of people. So here are some divisions now. Like they hire people for new product development. They hire just people for just generating CAD models. So they won't be into any engineering, but they'll just do CAD models based on input from the other department. So they'll be CAD engineers. Also, not the CAD engineers won't be doing the CAE. There will be a separate team that will be doing a CAE for all the parts. And some R&D teams, they'll do the CAD CAE by themselves, since they're doing research now. They have to be invested on the same product, so they'll be doing everything by themselves. So the other thing which I was not aware during college is the tool design and development. So every manufacturer, when you design a car, we just design a car, but from the manufacturing point, we have to design fixtures, toolings, and while manufacturing, robots have to take a car and place it somewhere. So we have to create end fixtures for the robots. So there is a big industry called tool design and development. So that you should be aware of. Also, there are some teams within companies which work on products that are already designed. They work to reduce the manufacturing cost in the design phase itself. So there will be teams doing that. And so here is a different team called process automation. I have seen it at my company, at my past company, and also I have seen it in Tata Motors also. So what they do is like they find a repetitive task within the company and they try to automate it with Python code or Excel macros or something like that. Say for example, if you're designing a bearing, okay, for selecting a bearing for a wheel, you will be needing certain requirements like weight of the shaft, diameter of the shaft, and weight of the car, and distance from the center of the wheel. These are few variables, and if you input these variables, you should be able to understand. Get the bearing model which you want to put in the car. So some engineers know they do build automation tools like that within every company. So this is a type of role. For people who are interested both in coding as well as in core, you can go. You can go to roles like these. And there are some roles like testing and validation. Once everything is done and the cars are done, they take data from the car and they try to understand how parts work and try to optimize the design later by giving those data to other teams. So we have a testing and validation team. These are different teams in design and development. I must have left out some roles. These are the roles which came to me my mind now. And we also have some roles in manufacturing and operations. Most companies like Hyundai, when they hire from India, they don't hire design and development team. They have all the teams in Korea. Also, Toyota also doesn't have any design development team in India. So they hire for manufacturing, operations, supply chain roles from engineering colleges. So you mostly involve in designing manufacturing process for a new car, and you will also see where time is wasted during manufacturing, how it can be improved. And you also research on new manufacturing process. For example, instead of MIG welding, you can go for laser welding, or you can go for 3D printing for a part. So those type of research are done by manufacturing teams. And there are people who work on plant maintenance, both mechanical and electrical. And here is something called supply chain. So people, when you see a car, it is not built by the factory itself. So I would say automobile is an integration of different parts. So parts come from different places and we try to integrate at the final factory. So when parts come from different places, we have to find who gives us the best part, and we must also work with the suppliers to make sure we get the right parts. So there comes sourcing vendor teams. So sourcing or purchase teams, they work with OEM standard parts like a spark plug for some infotainment system. So those are standard parts manufactured by some other company. So you have to set your requirements, you have to negotiate with them and source these parts from different parts of the world. So that will be the responsibility of sourcing and purchasing. So the vendor team also, what they do is they deal with fabricated parts. Say, for example, if you have a gearbox casing, it has to be manufactured by casting process. You have to find suppliers from somewhere in India or China to make that part in the lowest cost possible. Also, you have to deal with the suppliers. Say, for example, if the design team releases a new gearbox casing and there's a new update which can't be manufactured, you have to convey that back to design team and make sure that is fixed, and you have to talk with the supplier to change the tooling and all. So you can help the supplier to reduce the cost. So those are done by vendor management team. So there are teams within the plant also which does this activity from one department to another department. So they can be categorized under in-plant operations. So apart from all these, we have also technical sales and business development team. So you can't see this in automotive OEMs. You can see this in supplier companies. Say, for example, you are a company providing autonomous driving solution to another automotive company. Say, for example, you have to pitch it to the manufacturing company. Say, for example, Mahindra is producing autonomous car. Say you are from Bosch, you are providing autonomous solution. So there's another competitor called Continental. So you have to compete with them. You have to understand what they're offering, and you have to give something better than them, and you have to go pitch them to the Mahindra. So you should be technically strong as well as you should be having some business skills. So they come under technical sales. And business development, finding new suppliers, new business partners, and benchmarking other competitors, and framing go-to-market strategies. So they come under business development. Normally, we'll have less engineers over there, but you can go there. So these are some different roles in the current manufacturing industry. So the problem is we see a companies hiring less people in all these areas. So all because of new tools and new software, new intelligent hardware systems, and new design methodology. We require only less people to make cars nowadays. So in manufacturing, we have AGI robots. So this is a new innovation, I would say. Even nowadays, most factories are automated. I mean, they have robots, they have pick and place systems, servo actuated PLC control systems to make sure things are done automatically without humans. So even those systems, no, they require a lot of setting time. Say if you are buying a robot to pick and place a certain component from a place to another place, so the robot must be taught. I mean, we have to teach the coordinates. We have to make the end tooling so as to grip it properly. You have to. There's a lot of settings that has to be done to make sure it works. But there's some companies like Google, Visharia, they are building AJ robots. So they mimic humans. Like those robots, they need no setting. You can place it there, and it with those cameras and AI, they can automatically pick things and they can place it at the right place. They understand different things and they hold it differently. So these robots, no. So all this industry automation requires many engineers to set these things. So these robots might take all those jobs, maybe. Also, full factory automation. When a factory is automated completely, you might lose manual assembly labor. So that is also an issue. Engineers will be getting more opportunities due to this, but I mean, manual workers won't be getting any jobs due to full factory automation. So, and nowadays there are something called manufacturing execution systems. So, in the past slides we talked about ERP, QMS, PLM, and all. Okay, right? So nowadays, now there are companies building MES. So they connect all these softwares and they try to automate decision making between these tools. Say, for example, if you design something and the cost goes up, or something happens in the manufacturing line, and if something is halted, no. Nowadays, no, engineers have to go there, understand the problem, and make sure they'll do some changes and trade-offs at some places, and they'll get the manufacturing go. But these softwares, no, they do all these things automatically with the data. So even manufacturing execution systems might reduce human jobs, and these are related to manufacturing and operations. So when we come to design and development of cars, people might think it is a more creative job. We need engineers more there, but even there, we have almost reduced repetitive tasks at many places. Say even in my last company, no, we don't. We don't build everything from scratch every time. Say, for example, if we have already designed a table, if you want to design another table for another project, we have to just give some 2-3 variables and the CAD comes out automatically. So you save a lot of time there. Also, you will save a lot of engineers there. So that's how companies are automating stuff there. And also, we have knowledge management tools. Now, in past, no, engineers might have 15-20 years of experience. They would have learned a lot during the journey. So that guy might design parts more in a more better way than other engineers. But nowadays everything is clearly documented, and there are companies which depend on the past data. They have taken those data and made present it away to new engineers so that they can build on top of the world learning. So knowledge management tools also reduces number of engineers by increasing the productivity. And also, if you see the supply chain department, nowadays engineers, they do it manually. They call vendors, they meet vendors, they select suppliers based on their quotations. But here also we have many tools, like based on the capabilities of a certain manufacturing partner. Say he has 3 CNC machines, everyone has 10 micron accuracy. Based on that, you can give orders to him. We don't go directly and visit him and do an audit, and everything is going to get automated in that space also. I mean, many companies are building solutions for that also. So with all this now, we have an increase in productivity. So fewer jobs will be there for current roles. It doesn't mean like we won't be having jobs at all. We'll be having fewer jobs for the roles which are available now. And if you see more now, lots of these manufacturing companies also hiring roles for data analytics. They're hiring for programmers to build these systems. So there are a lot of job opportunities coming. So this is going to be the last slide, I guess. Yeah, so we made this slide to make sure, okay, if we were at college now, what we would have done differently. So we thought in that way and came with this. Yeah, basically I would say we should be strong in basics. If we are strong in basic math, physics, chemistry, and engineering basics, we can learn anything later. So yeah, that's one advice I would give to everyone. And the one thing which I missed in college is like we learned a lot during the college, and I didn't make proper notes. I mean, notes which are accessible later. So nowadays we have a lot of note taking apps, right? So you can make sure you can those notes are accessible later. So say for example, if you studied a bending equations at in the second year or first year, maybe you might not remember it in the fifth year into your company. You might go to search it again on Google and learn it again. But if you have a pre-recorded notes now, if you see that, you will be able to understand it much more easily. So that's one. And yeah, you have to be creative. And during college, you should always hunt for problems to work on. If you're really interested in engineering, you will be always looking for problems. And if you're creative enough, you can come up with new solutions. Also, one thing when myself in college, so I used to compare myself with someone from my classmate or someone, but don't do that. Compare with yourself with everyone around the globe, and make sure you, if you want to do something better, you make sure you stand out from everyone in the world. So that's a way of thinking differently. So I also suggest you to read more books, articles, patents, and blogs regarding any topic, not just automotive, transport. You can read about anything. You start with books. Maybe blogs are easy to read, but books are where you can get the fundamentals strong. Then go to research articles and patents, then come to blogs to understand the gigs. And when you read books, articles, now you will start writing blogs. But if you read blogs, you won't be able to write blogs. Also, you should not stop consuming. I mean, only consume content. You should also produce content or build stuff. So that's advice. That would helpful. That will be helpful to solve problems in future also. Also, when I see mechanical and electric, I mean electrical also engineers, make sure you learn all these tools also. Even though if you work at a company as a mechanical design engineer, you can solve a lot of problems in your industry. Also, you can automate stuff by learning all these tools. So learning these tools will be helpful going forward. Also, since number of engineers recruited by automobile industry is going down, you should shift to other industries like space, sustainability, new energy. So there are new companies that are to be built in these spaces. They are not in India. Maybe you can also build companies in this space. And the last one, yes. And the last one, everybody are doing nowadays. You make sure you follow that, doing internships at different places. And Lakshman Maraval, if you have anything, you can add to this slide.
This is summarized good. All these are good. Like just be consistent. Like put in your efforts consistently.
Yeah. So I guess we are.
Yeah, at the end of this session, like if you have any questions, then you can go on.
I thank the speakers for their wonderful and intriguing speech. Now, participants are kindly requested to pose your doubts to the speakers by either putting them in the chat box or by unmuting and expressing yourselves to the speakers accordingly.
I really appreciate you guys listening to all these in Sunday evening.
Yeah.
I would not have attended this if I was studying first year or second year at college. Yeah, please feel free to ask questions, any random questions.
Not only about
the
the session, but any random questions
about the industry.
This session was just to give you an idea of how things work at an automotive industry. Like, but you can ask any questions.
Where do you do your internship? Yeah, internship. Say it depends on what you want to learn. If you go to, say, for example, you can start by doing visiting or doing small internships or trainings in manufacturing plants within your area. Say, for example, around our college we'll have some manufacturing plants, so you might not be aware about how things are actually made in the real time. So that would be a good starting point. Maybe if you are interested in design and development, um, uh, you can reach out to companies or alumni working in those companies and ask for internship.
What ideas you have?
That's a question. Why I have wipers in the first place
Yeah.
when if you don't have windows? I mean glass. IT, which is better, core or IT? So Gayatri, I think Lakshman Perumal, you can answer Rohit's question.
Yeah. I'll go through it. Like,
Yeah. So that's an interesting question from Gayatri. For mechanical and production engineers, which is better, IT or core? So to be honest, no, IT pays you double than core. So if you see from a benefit standpoint, you get to learn a lot. I mean, earn a lot from IT. So if you see IT as general, no, so they do. They are nothing but they build systems for other companies. Um, so if you are from mechanical and production background, and if you join an IT company, you might not be getting working with manufacturing companies alone. You might be working with different companies as well. So if you're really interested in the core field and if you want to earn as like IT people now, you should be working in a conjunction of both industries. Say TCS has their own industry automation division, so they get orders from different companies. So what they do, TCS no, so they have a division called they do provide full factory automation for big companies. So TCS, within TCS, in that team, they'll be having software engineers, mechanical engineers working to provide that solution to their customer. So yeah, you get both core. Nowadays, it is going to merge together. I won't be saying IT and core will be different. They are going to merge together. Satish has a question. Hydrogen fuel cells are not yet. Firmal, do we have hydrogen fuel cell research at Mahindra?
Mahindra, not as such Mahindra, but Mahindra has a company owned. Mahindra owns a company called Pininfarina. So Pininfarina does hydrogen fuel cars. So you might be aware of Battista car. So that is powered by hydrogen fuel cells. So the thing in hydrogen fuel cell is it is not. It is feasible, but it has to go a lot of research, like to package the cylinders and make it uh, uh, packageable. So there are researches going on in hydrogen fuel cells. Indian automobile industry. Okay, not every Indian OEM has an division for alternative fuels. So people are working at hydrogen fuel cells. Not in near future, we might see a hydrogen fuel car, but we will get to see it somewhere far. Yeah.
So internship for first years. Yeah, you can get internship during your first years. Yeah, your starting point should be some manufacturing company. If you are in manufacturing domain or mechanical production, your first year should be visiting or having some internship within some manufacturing facility around your college. Maybe if you want more exposure and if you want to go to big places, you can start right away start with applying for big companies even in your first year if you are ready to learn. So the problem here is if you go to some companies for internship now nowadays, I mean most companies, what do? They give some manual tasks for the student. I mean, say for example, you go to a team and they say, okay, fill this Excel sheet for us, do this for us, do this drawing for you. You might not be learning a lot there, but you will be getting the industry exposure. When you apply for internship, go for a very smaller company or a very focused team. So you might be actually working on some problems.
Choose your internships. I would say choose your internships other than go for an internship that is available for you. Like if you want to learn something, you have to search for that and apply to that specific company or specific team or a specific professor working on that problem statement. You can do internships in other educational institutions also, like IITs or IAST. So you can approach the professor through email. So they will respond to you, and you can work under them as an internship. So if you're really interested in, for example, if you're really interested in welding technology and you want to bring up, like contribute something there, and some professor is working on the particular welding technology, I would suggest you go up, talk to that professor through LinkedIn or email to them, and you get to know what they are working on and how you can support them, and there will be a mutual learning there. So not only companies but also research professors offer internships in all those institutions. So you can take that too. Yeah.
Yeah, Anurag has asked our phone numbers. Suntra, maybe you can share our phone numbers to him or to the participants if they want. And Sarana Kumar has a question. Suggest some projects related to CFD. See, Sarana Kumar, the mistake which I did, I mean, most of us did at college is learning tools and not the underlying math. Say, if you take FE or CFD now, first you have to understand how those things work on the back end. What are the numerical methods go on? How do these, how do these finite element equations are solved? How do we form matrices? And you have to be a little, you should have some good exposure on the math stuff and the actual physics behind the CFD. And you should start with simple CFD projects. Even if you say, I know to do CFD on particular stuff at a company, when you go for internship, or you might be knowing to use the tools, but at companies now you have problems. The companies might not require you to know the tool in the first place. Even at my old company, they didn't want me to learn FE or CAD in the first place. They wanted me to learn engineering basics of engineering first. So if you know the basics, if you are strong in basics now, you can do anything on the tool. So yeah, if you are going to do projects on CFD, first study the underlying math. Okay, someone is asking me about analyst role at Axion. Okay, so Axion, there is no general role for me at as analyst at Axion. So what they're trying to build is like a decision-making system for automotive companies. So we need to talk with a lot of companies, automotive companies, and get their data and build solutions for them. So right now at Axion, we have some data scientists. So I am helping those data scientists to understand automotive data. So that's my role at Axion right now. So it's not like I wanted to be an analyst at Axion. I was working as a mechanical design engineer at Titan. So I saw this opportunity. I thought it will be interesting. So I went. Maybe so they hired me as an analyst only because I worked as a mechanical design engineer for the past 2 years. I mean, past 1.5 years. So you might not straightly land up at analyst post. So generally analyst post now they just do work with Excel, SQL and stuff like that. So here I have to work with that. Plus I should have some automotive knowledge. So that might answer your question. I guess we are done with all. I mean, we have answered all those questions on the chat
That
box.
Rohit
I think Lakshman Parmal, you missed that idea. I mean,
Yeah,
Rohit
so
asked you a question.
that was just for an ideation session. Uh, I took that example. Just it came up to my mind while preparing those slides, so I just kept that as an example. As such, I have not generated
But
any
you should
idea,
have some ideas, right? Okay.
but that might be patentable, so I can't declare here.
Yeah, if you see a problem and alternate solutions in the first attempt, no, your mind will be going to those existing solution. You'll develop a bias to the solution. You won't be thinking outside. So whenever you get a problem, you just forget about the solution and you start writing your own solution. Then go back to other solutions.
Don't get constrained of the feasibility of the solution. Like if don't just think like while ideation, don't constrain yourself. Like this might not be feasible. just put up your ideas, then we can see whether it is feasible or not.
Okay, Saranamar has an interesting question. Influence of
Influence
AI.
of AI.
So AI is going to take all our jobs. That's going to be true in the next 5 to 10 years. AI and automotive. Yeah, when you see all the industries now, yeah, AI is going to take all the jobs. I'm not sure how things going to be in the next 5 to 10 years. In the automotive industry, say if you have all data from all the process now, you need no humans there. You can write code to do some stuff, or you can build some AI system to make decisions based on the data. So yeah, once all we were able to collect data from all the manufacturing plants and all the process and able to leverage the data, yeah, soon we'll be out of jobs, or maybe we'll be doing less manual or laborious work. We'll be doing more creative work and let the AI do the manual work in future. Maybe Lakshman Perumal just will think about the idea, and all the material selection, the design will come out of the AI software. Yeah, that is going to happen for sure.
Currently in OEMs, if a dataset is mature enough, then we can implement AI. So not all datasets are mature, so we still have time. Yeah,
Yeah.
don't worry about
So
it.
nowadays AI they use it for autonomous driving only, and even for part design there are numerous research papers. And if something can't be mathematically modeled easily, you can't model it with calculus. No, then they easily go with statistics. They take the data and they do form a equation out of it. But most of the problems in automotive industry, they can be easily modeled. They are not. It is not like image vision, or it's not like natural language. So everything can be easily modeled in the industry. So right now, yeah, there is only application of AI is in autonomous driving, and other stuff will soon follow in automotive industry also.
Sir, it would be great for us if you could tell us about your personal experience from picking up the problem statement and the researching and ending up with the patent. We would be allowed to hear that.
Okay, so yeah, during the third year now, so I was working on a mini project for my third year semester 6, I guess. So it is not like you can't patent everything and anything. You can patent anything and everything if you have some novelty inside it. So when you think about patents now, if you are going to do some project just for getting patent, it's fine. But uh, there are two types of patents. But first, I would say a utility patent as well as a design patent. A design patent is something you get it for the external appearance, so that can be easily granted for anyone. Say, for example, if you design a phone case by yourself and add some extra elements, and if filed for a patent, you might obviously given a patent, a design patent. So the utility patent is a tricky part here. Okay, to get a utility patent, the amount of work that goes into a patent is huge, and the amount of research that has to be done on getting a patent is very huge. And I've not seen any. It's really difficult for undergraduate students to do that. But you can work as teams, and say, for example, if you're doing some third year or final project, you can work on a specific problem from a bigger problem set, and you can try to solve that from as a team, and you can bring out something that is patent worthy or publishing worthy that can be published. So that would be an approach. Or also connect with proper professors and staff from the college. They would have already published many patent. So it is more of a regulatory work, and the application framing is more of a law work. So they might be helpful in getting a patent or getting your research published.
Ajay Kannan has a
Ajay
question.
we have
Yeah.
audience out of scope also.
So I've told various departments, right? So my wish is to work on a particular department, and your question is whether will I be allowed to work on that or not, right? So yeah, it is possible. I can connect with my team and connect with my HR, and get to that particular department of my interest. So if the vacancy is not available, then they will be uh, putting me up in some other department for a shorter period of time, and then I will be moved to that domain of my interest once the vacancy is there. Next, you will ask why will it if the vacancy doesn't open up, then I should move out of that company.
Ajay Karan, also the other thing is like when you're graduate engineering trainee or if you join a new company, you might not be knowing the pros and cons of being in a department, a particular department. Say when I went to Titan, now first I was asking them to put me in COE, a Center of Excellence department, where they do research for new machines and all. Okay, but they put me in. They want me to put in technical sales or mechanical design. So I thought mechanical design will be more closer to CAA, and I chose mechanical design. But now I feel I should be in technical sales, because when I go into the actual work now, so I understand more about the work. So mechanical design is like more on working concepts from technical sales. So technical sales people are one who think different and make the concepts. So it is more interesting work than making concept on a CAD model, CAD software. So I felt technical sales to be more math involving and more thinking, more creative than mechanical designs department. Yeah. So you might not know about a particular role until you go there.
You might think the role might be challenging, but the actual scenario might be different.
Reason to leave your company, old company. So Kishore, it will see. It might be difficult when you study at college, in final year or third year. You will be seeing placement. Those guys who got placed from campus now, you may think like it's a big thing, but it's not a big thing actually. You can easily land up at a job after final year. There are many ways to get into a job. Once you get into a job now, it is very easy to get into another job which has more benefits or which you like more. So I like the role at Axion more, and so I went there. So there is nothing more than that. Can we do internship at Tech
Internship.
Mahindra? So Tech Mahindra is IT company, yeah,
Yeah.
but you can obviously join Tech Mahindra if they.
What kind of CAD software will be used in companies like Mahindra? Uh, CAD software. Each OEM has its own preferences. Like different CAD softwares are available. We Mahindra we use CATIA, NX CAD, but other OEMs will be using Creo, SolidWorks. All those softwares are available. Like software is just a tool, like right. So people who design must be creative enough to bring in the optimization in the parts.
Yeah, we at Titan used Inventor. So nobody asked me if you know Inventor or not, or if you know CAD software or not. Nobody asked me, because when you are done with the college, or if you are in any year of college, you can learn any CAD software in 10 days. If you just know, you use only 10 or 15 features on a CAD software like extrude, cut, revolve, feature pattern. So you can learn CAD, any CAD software in 10 days. So no companies will matter that most. If a company matters CAD software more, you should not go to that software company.
Yeah, correct. Software is just a tool, so don't get
Yeah.
behind softwares. Just be strong in your basics. Creo எங்கெல்லாம் யூஸ் பண்ணுவாங்க? Uh, other OEMs, Tata Motors are using Creo. Not only Tata Motors, but few other OEMs.
Nowadays, people don't use Creo at all. They use most people use either some software from Dassault Systems or Autodesk system. I mean, they two are the market leaders now, I would say. And I mean, Siemens also, NXCAD. Siemens, Dassault Systems, and Autodesk. These are the major players in the industry now. Also, please don't call sir anybody sir again.
Yeah,
It's not good.
they're
Even we
just
don't call
seniors.
Also, it makes us feel old. Yeah, thank you guys.
Yeah,
I
thank
guess
you.
Santra, we